They are a mass extinction threat to us if they are near the Earth, but some of them consist of precious metals. Will this ever be practically feasible? We are speculating about what if we started asteroid mining in today's video of Discover Zen. There are millions and millions of asteroids available in our solar system. According to some scientists, the asteroid belt around Mars and Jupiter is estimated to contain between 1.1 and 1.9 million of these space monsters, which are more than 1 kilometer or 0.6 miles in diameter. But we don't have to go that far to mine them because there are more than 20,000 known near-Earth asteroids. These are easily reachable using our current rocket speeds. Based on the composition, there are 3 types of asteroids. The first common type is C-type or chondrite, making up about 75% of known asteroids. They are very dark in appearance and probably consist of clay and silicate rocks. They are among the most ancient objects in the solar system. C-type asteroids mainly are in the asteroid belt's outer regions. The second type is S-types or stony ones. They are made up of silicate materials and nickel iron, and accounts for about 17% of known asteroids. They are brighter than C-type and they dominate the inner asteroid belt. The third one is what we are most interested in. These are M-types or metallic, made from nickel and iron. These account for about 8% of known asteroids. They are brighter than C-type and they can be found in the asteroid belt's middle region. Now let's discuss about asteroid mining and what are some of the pushbacks in the process. The first thing to note is that it's nearly impossible to land asteroids on Earth and mine. Our technology limits this from happening even if it's more valuable. Our next option is to mine the asteroids in space and bring those raw materials back to Earth. But even this would not be too profitable for the long term. The next concept is to build some space station near the asteroid belt and use those raw materials to create rocket fuel and further explore the cosmos. We need to scale the size of our current space station by at least 100 to 200 times for this plan to be feasible in the long run. But let's imagine a scenario where we can bring mined materials to Earth and make it profitable for us. In this situation, hard rock minerals could be mined from an asteroid or a comet. Precious metals such as gold, silver, and platinum group metals could be transported back to Earth, while iron group metals and other common ones could be used for construction in space, and we might be able to build a space colony after several years of mining. Many asteroids are estimated to be filled with icy water, and that can be useful if we are really interested in space exploration. Our current physics understanding would be more than enough to mine these space rocks, but our technology limits us from operating cheap and easy space missions. Another problem is that our prediction for the type of asteroids is not quite accurate. The last and most important concern is regarding automated space travel. It is extremely expensive, as we need to export machines from Earth, at least for mining the first batch of asteroids. Asteroid mining seems logical, as we are exhausting all the resources on our blue planet much faster than it should be, but it is not really feasible for now because of our current technology limitations. But what if we invent a machine which could provide us unlimited energy? What if we invent a working EM drive? Well, that sounds like a different topic to speculate and investigate on Discover Zen.